All right, we have y equals secant x at pi over 4. Is that right?
Yep.
Okay. What is y?
Radical 2. That's right.
Yeah. Radical 2?
Yeah.
Good, because that's what I got. So I have this point, don't I?
Yes.
Now what do I need to find in order to write the equation of a tangent line?
Slope.
How?
You find the derivative and then
What's the derivative?
secant x times tan x.
Should I change this if I have it all in decimals?
It's going to end up in decimals.
Okay.
I'm just trying not to put that, yeah, but it's going to.
Okay.
All right, we here?
Wait, so why do we need to find that point?
Find what point?
Right.
To write an equation of a tangent line, I need x and y.
Oh, okay.
That's why. So what is m?
Radical 2.
M is
Radical 2 times what? Isn't tan x
okay.
10 pi over 4?
Oh, yeah. So it's just,
So m is radical 2.
Yep.
Right?
Yep.
So don't I have y minus radical 2 equals radical 2 x minus pi over 4?
Mm-hmm.
Why? Because you're going to go 2 decimals now.
Wouldn't it just be y is radical 2x?
Radical 2x, huh?
Minus pi over 4?
No. Because isn't it y equals radical 2x minus radical 2 times pi over 4 plus radical 2?
So with the radical 2's not cancel out?
No, because this one is times and that one is plus. So you just put this in your calculator?
Okay.
And actually, radical 2 is 1.414.
Mm-hmm.
So,
So on 21, you want us to add the pi.
Yeah, I had the same question.
you don't have to.
Okay.
But if we did put it in decimal, I just rounded to 3 places.
Always 3 places.
Yeah.
Always 3 places.
But you don't mind if we did that?
No.
Okay.
I had to define a number. So.
Now, that's the tangent line.
Oh, yeah.
So
What's the normal line?
opposites reciprocal.
So this time, isn't it y minus radical 2 equals negative 1 over radical 2 x minus pi over 4?
Mm-hmm.
And you're going to have decimals again.
Is it bad if I, like, got rid of the radical on the bottom?
No. No problem.
I like these assignments.
Do you like these assignments? Well,
And the last
I would like to say today is similar, but it is in some ways. I'm not sure how I'm going to do today's. It's going to be a trick.
I think I just like assignments whenever I'm actually here.
That makes a bit different. If we had an equation that looked like this, and I asked you to take the derivative, didn't we FOIL it out and then take the derivative?
Yeah.
Okay, what happens if I have an equation that looks like this? Now foiling it out,
It's easy.
it's a little harder.
Mm-hmm.
So when we get to this point, we use what we call the chain rule. And the chain rule is like an M&M. This M&M has an outside or a shell, correct?
I wouldn't say so.
And the shell is totally independent of the inside. Is that right? Totally separate. Now, if I were to eat this M&M,
Oh, wow, shaded.
Would I eat the shell? Would I bite the shell first or the inside? The shell.
Yeah,
Unless you shell on it.
So, well then the shell comes off and then it's really good.
Oh, yeah.
Mhm.
what I like.
That's where it's at.
So, when we take the derivatives using the chain rule or the M&M method, we do the outside first. The outside of this is the 5. So when we take the derivative, we only take the derivative of the 5th power first. Doesn't that bring the 5 out front
Yeah.
and change my exponent to a 4? So I take the derivative of the outside and I leave the inside alone. Because when they put that coating on an M&M, they leave the inside as it is, don't they? So my derivative is starts as this.
We just keep going.
Then you eat the inside, right? Once I
Take the derivative of the inside and you just flip flop back and forth.
And do these off.
once I eat the outside of this, then I eat the inside, correct? So I have to take the derivative of the inside. What's the derivative of the inside?
1.
No, x to the third. Yeah, that's what I meant. That's what I meant. 1.
Oh.
There's confusion. 1.
Let's do that again.
1.
0. It's like eating a parasite. You eat it from the outside, it eats you from the inside.
What?
Eating a parasite.
You eat it from the outside in, and it eats you from the inside out. It's a good one, Hunter. I like that.
Yeah.
Okay,
Wait, was that right?
Wait, so that's the derivative?
that's the derivative.
So we don't have to keep going.
So the answer's 1?
No, the answer is 5x to the plus 3 to the 4th times 1.
Or is it 5?
Yeah.
Okay, so here's my M&M. What do I do with the M&M? Inside or outside first?
Outside.
Outside.
I usually take out the shell, eat the outside, and then eat the shell.
So it is a 7 times 3x squared plus 5 to what? Now, once I eat the outside, then you eat the inside. What's the derivative of the inside?
6x.
So the question.
So my answer is 42x times 3x squared plus 5 to the 6th. What?
Why couldn't you do the inside first?
Can I eat the M&M on the inside without touching the outside?
They're completely different. You can get the derivative.
Because you do what I tell you to do.
Yeah, Harrison.
Okay.
She's smarter than you.
Because we're getting ready to go
Crazy.
to another layer.
Oh, and then you're gonna have to eat the inside.
The peanut M&M.
You got the
Does this make sense to you?
Yeah.
It does?
I think so.
Okay. This one is a peanut M&M. Because
I didn't like the
I always do my peanut M&Ms first.
all right, this peanut M&M has a hard shell.
It does.
Inside it has chocolate,
Uses.
and inside that is peanut. So it has an outside, a middle, and an inside. So when I do this, derivative is the same thing. If I were to work this problem, if I were to tell you what x is, tell me how you would work the problem. Would you plug in x? Right?
Or to tell me what x was.
If I were to give you an x, would you plug in x? Okay. Then the second thing I would do is take the sign of it, right? And what would I do last?
multiply for the fourth power.
Okay, fourth power. So when I take the derivative of this peanut, I go backwards, and I only do one step at a time. I do one step, leave everything else as is. The next step, leave everything else as is. And the next step, all right? So my last step was the fourth power. So when I do the derivative, that's the first derivative I take, the outside, right? So isn't it 4 sine 3x squared cubed? Correct? I notice that I left, I'm missing a parenthesis, aren't I? I left everything in the middle alone.
Yeah.
Then, the next step, I'm going to take the derivative of sine, which is,
Cosine.
and I'm going to leave everything else alone. So I have this. Excuse me, you agree? Then, the derivative of 3x squared, which is what? No. So is my derivative 24 sine cubed 3x squared times cosine 3x squared?
Shouldn't it be 24x?
Yeah,
Oh, yes, thank you.
thinking of the space, not
Okay, that makes.
Does that make sense?
So.
This has my germs, so I have to eat it, right?
no. You can call it thinking.
You can't have my germs.
It hurts.
Does that make sense?
Yes. I just had a peanut in my mind.
So what happened to the fruity wire? Wire to the third power.
So I would just.
Oh, that went to the side. Okay, maybe the trunk.
So yeah,
Maybe it was.
okay, so yeah, literally just taking the derivative and leaving. Okay.
So, if I give you a problem, that looks like this.
I can have cube root inside of the fourth.
No, it's outside of the thing, so.
I can have fourth root.
Is this the same thing as what power?
1/4.
Well, 1/4.
3/4.
3/4.
Isn't it 3/4?
Wait a minute, why is...
Because of the 4 and the 3.
So, is this an M&M or a peanut?
He's just in it.
It's just an M&M.
Okay. So 3/4 minus 1/4.
Wait a minute.
1/4
Wait a minute. Isn't it 3/4
times 2x to the fourth
2x?
Negative.
plus 2 to the negative fourth power times 8x to the third. Make it whatever 3/4 times 8x is.
Wait, so that's supposed to be 4?
Yes.
4, which is 6 over 2.
Wait a minute. So it's what?
6.
So is this 6x cubed
Third
times 2x to the fourth plus 2?
minus. Good work, Kaylin.
You always combine what you can combine. Does that make sense? Can we do this?
I mean, you can is
I have the ability.